Hello there, my name is Vakile. Welcome to the program Engineering Tidbits, Electrical Engineering Tidbits, where we discuss electrical engineering principles and we also discuss the design part of circuits and then the commissioning part of it. So today we have decided to look at resistors in parallel, resistors in a parallel circuit. So let's look at this circuit here, and this circuit has a battery here, which is let's say this is a positive and this is a negative, and our battery is V, and that's its voltage is actually impressed across those resistors. Now what happens when resistors are in parallel? There's the same voltage which is across R1 is also across R2 and R3, so they're experiencing the same voltages across them. And with respect to current, when current gets to these junctions, junction number 1, it splits into I1 there and the other one goes there, then I2 into there, and then the other one, I3, goes there. Okay, R3 goes there. So specifically speaking, if you look at that, current that is flowing in there, the current that is flowing in there is I3. The current that is flowing in this circuit is I minus I1. Okay, that's the current that's flowing in there. Okay, I minus I1, which is already turned into resistor 1. So that's what we have there. And but that's not important. What is important is it's good to know it, of course, but for the purposes of this analysis, let's say analysis here. Want to analyze this circuit. Now, to analyze this circuit, you have to you actually have to account for the current. So we know these formulas. V is equal to IR, I is equal to V over R, and R is equal to V over I. That's what we know there. So we know those three formulas. So 1, 2, 3. So we're going to use these formulas. So we want to find the total current that's flowing or that's being drawn from the battery. So I is equal to I1. Ultimately, I1 plus I2 plus I3. Because there is no other place where that current is going. So it has to go there and come back. And you find that the current that is flowing in there is actually I again. Down there, from that junction onwards, is I. Okay, so that's what we're saying. This I here, I is, well, current in resistor 1 plus current in resistor 2 plus current in resistor 3. Okay, so let's analyze, let's substitute here. But I is equal to V over R, equal to V over R equal to V, because the same voltage is present across those resistors, so it's got V over R1 plus V over R2 plus V over R3. Okay, so far so good. Now we can divide by that voltage there because it's common. Okay, first thing that you might want to do if you want to be systematic, you factorize V outside the bracket, 1 R1 plus 1 over R2 plus 1 over R3. And if you want V times 1 over R. Okay, so we can actually divide by that, okay, by V. And then we are left with 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this is our equivalent resistance here. So we can proceed, put them under the same denominator, and then we find out, we take the reciprocal and we find out what R is. Okay, beautiful. So this is a nice thing. Now let me give you a special case when there are two resistors only. In the case of two resistors, let me take my eraser there. two resistors. We go back to that. Okay. So in case of two resistors, there is I1 flowing there and I2 there. So using the same analysis, we're going to find out that V over R, R being our equivalent resistance, is equal to V over R1 plus V over R2. Okay, now you can immediately cancel the V's because they're the same. So you can cancel that V so that you get 1 over R is equal to 1 over R1 plus 1 over R2. Now you put them under the same denominator here. A common denominator is R1, R2. So R1 goes there R2 times 1, you get R2 plus. That one goes there R1 times, okay, is equal to 1 over R. Okay, that's beautiful there. Taking reciprocals, you take a reciprocal of that and a reciprocal of that, you get R is equal to R1, R2 over R1 plus R2. So this is beautiful. That's the beautiful formula there that we get. And I just want to put it in red like that. That's a beautiful formula there. We can do a simple example to show you the resistances. Let's do a simple example just in red. Say R1 is equal to 3, R2 is equal to 4, and our voltage is equal to let's say 14 volts. Oh, let's put back the 12 volts. The nominal most voltage are 12 volts. Okay. Now, just to calculate R will be equal to what? R is equal to, you use that equation there, R1, which is 3 times 4 over 3 plus 4, which is equal to 12 over 7. Okay. Now our current, we get it from here, V over R. So our current I is equal to V over R, which is equal to 12 volts there over 12 over 7. Now you know how to divide by a fraction there. That goes upside down. We're going to have 12 times 7 over 12, which is equal to 7 amps. So we actually get 7 amps in that circuit. Okay, so this is the thing. And the other thing that we might want to do is to find a voltage. Suppose the voltages are unknown here. Let's do that. Or suppose we actually let's reverse this one. That we have 7 I is equal to 7 amps. V is equal to 12 volts. R1 is equal to 3 ohms. And what is R2 equal to? So that's pretty simple. All we do, we just come to this here. We go back to that. R is equal to R is equal to R1, which is R1 is 3 times R2 over 3 plus R2 is equal to R. So we go straight to find the current. I is equal to You remember that I is equal to V over R, so we divide by that. I is equal to 12 over 3R2 over 3 plus R2. Now, that thing there is equal to. Now we know that I is equal to 7 amps. 7 is equal to, that one there becomes 12 times 3R2 times brackets 3 plus R2. So you solve that equation there, and you should ultimately get 4. Okay, that's what you should get. R is equal to 4. I'm not going to do that. That's a simple equation there that you're solving there, because all you need to is to multiply to there. Get 21 R2 is equal to 12 times that, which is 36 there, and 12 R2. Then 21 minus 12 R2. Okay, you're ultimately going to get that kind of stuff. So let's simplify the equation first, and then you can solve it anyway to get R2. Cross multiply 21 R2 is equal to 36. We're multiplying the 36 plus 12 R2. Now you can subtract the 21 minus 12. 21 minus 12. You get what you want there. Okay, so that's it there. You can solve for your R2. Okay, 21 minus 12, you're gonna get 9 R2 is equal to 36, and dividing there by 9 over 9, you get R2 is equal to 4. So R2 will be equal to 4 there. Okay, sorry it had gone down there, so that's what you get 4. That's it for now, guys. Thank you very much for this beautiful watching. I'll come back to you with another beautiful tutorial so that we continue with our power systems electrical engineering tidbits. Cheers.